Welcome and thank you for attending this track. Welcome to Application Modernization. My name is Donnie Prakoso. I'm a technical evangelist and I'll be your host for this session. So I know some of you are coming out from Singapore. Just wanted to quick check. How many of you are based in Singapore? Awesome. Okay, so how many of you based not in Singapore? Okay, so give a round of applause for them who are coming to Singapore for this event. So in this session, I'm going to share my knowledge about microservices. It's becoming the de facto approach when you're building your system, but there's a few key challenges, and I would like to share with you how AWS can help you by presenting 4 best practices. Okay, so first thing, monolith. Okay, so this is the approach that we've been using so many times. If we want to build a system, we build all the services into a one large code base. Okay, so the key characteristic are, first, all the processes are tightly coupled, right? And we usually run as a single service. And because we're putting all of those functions and services into one large code base, it becomes really complex as our code base grows, right? And as complexities, it's limiting the experimentations. It's limiting us on how we can roll new features to satisfy our customers. Right? And when it comes to scaling, the entire architecture needs to be scaled. And this will impose a risk for application availability. Okay, so I started with monolith. I understand the key challenges. And then moving on to the next slide, and what do we need then? What do we need to need to improve our system? We need to be more agile. We need to be more agile to satisfy our customer by releasing new features into our product. That's really important. And we need to have the flexibility to implement more technology. There's a tons of libraries and really great frameworks out there on the internet that we can use. It doesn't make any sense if we need to stick into one particular technology because the limitation of monolith. And by doing so, it gives us the improvement in terms of our code. We can have quality code. We can improve the reusability, the composability, and the maintainability of our codes, which we can deploy our codes to make into our system much more easier. And then by having an easy deployment, we also need to be more flexible in terms of scaling. But we don't stop there. We need to have a resilient system. Okay, so there's a lot of demands. So there's a lot of demands that we need to solve. So I want to introduce you to microservices. Okay, so quick question. How many of you have implemented microservices on your production? Oh, awesome. Okay, so microservices is an approach both on 2 dimensions, architectural and organizational. It reflects to your organizational structure. It's an approach to software development in which we have our software composed of a small independent service that they really well communicated over a well-defined APIs. Okay, so that's the definition of microservices. To give you a big picture, this is how it looks. So on the left side of the pane here, we have the illustration of monolithic. Let's say you're building an e-commerce application with a monolithic approach. You have to build your order UI, your front end, your web, and then you need to build your order service, inventory service, supply chain management, shipping service, everything, and wrap into one large service, single service. That's monolith. But when it comes to microservices, we take out of those each components into one independent service. So you can see on the right side, we have the order UI. We have order service, we have inventory service, we have shipping service. It's all the same. The difference is it's now running as a single independent service. Okay, so you see that I put a number there. That means that you can easily scale all of these services independently. So let's say that you have this like a promotional marketing activities going on for your website, e-commerce website. The first thing that you need to scale, that you need to be scaled, is your front end. Right? It doesn't necessarily to scale the inventory service or shipping service. So with microservices, you can scale only the order UI. That's why I put the number n on the right side. So, and then that's the key characteristic of microservice. It's decentralized. Decentralized means it's a distributed system with a decentralized data management. And then on microservices, we are building an independent service. This independent service is a different components that can be changed, upgraded, or replaced independently without affecting the whole system. And then it's black box. Black box, as it means as it's abstracting away the complexities of one service from another service. So another service, it doesn't need to understand the complexity of one service. It only needs to communicate over well-defined APIs. It's polyglot. This is what I like. You can build your system with microservices approach using a heterogeneous components. You can build using Go language. You can build using Python. You can build using Node.js. Anything, as long as it communicates well. And then you build it, you run it. It's the ownership of your team. So one team can have one microservice, and then it only do one thing very, very well. It doesn't mix with another domain. Okay, so that's the key characteristics of microservices. And to give you an example, I would like to bring up the case of Amazon S3. Anyone here use Amazon S3? Oh, nice. A lot of you use Amazon S3. So Amazon S3, they started with 8 microservices. And up till now, we have 235 plus microservices to serve your needs. It can host your static website, or it can be your data lake, or when you upload your machine learning artifacts on Amazon S3. Everything is being well coordinated and handled by all of these microservices. However, there's a challenge on microservices. Same with monolith. There's a challenge on monolith. And there's also few challenges on microservices. So I'd like to start with the Conway's law. So the Conway's law says that the system design is largely influenced by the organizational structure of the teams that build the system. Okay? So what does that mean? That means that the way you structure your organization, your team, it will reflect on how they build the system. If you structure them and then they have the problem with communications, it will reflect the same on your system. Okay, so and then we have from the organizational structure, we have other few key challenges. The first one is the migration. It's hard to migrate from monolith to microservices. It's hard to break down all those services into microservices. And there will be a lot of versionings. And also, it's tough to build a distributed system, because microservices are effectively a distributed system. You cannot assume that the network is reliable. Don't assume that. You cannot assume that the latency will be 0. You cannot assume that. So one thing that I've learned when building the distributed system is, if you're building the distributed system, please expect distributed problems. Okay, so and then so we've been helping our customers on how to build microservices. There are tons of questions from our customers. What is the best way to build microservices? And this is a few questions that we got from them. Like, how to deal with asynchronous communications? Oh yes, we know synchronous communication. But can we use asynchronous communication for building microservices? And then how to operate hundreds or thousands of microservices components? Because when it comes to microservices, you will be dealing with a lot of components. Not only components, but also versioning. And how to manage that. And because we're building a distributed system, and how to track and debug all those interactions across the whole system. And how to ensure the proper level of decoupling between one microservices to another microservice. So to summarize everything, there are two kinds of complexities when dealing with microservices. The first one is the architectural complexity, and the other one is the operational complexity. Okay, so in this session, I'd like to share with you 4 best practices as a journey to reach the hyperscale microservices by the help from AWS services. The first best practice is to think a container-first approach and orchestration tool. That's really important. And the second best practice is how to automate the software release process, CI/CD. And the third best practice is on how you can utilize asynchronous communication and lightweight messaging. And the last one is you need to know your resources better with service discovery. Okay. So let's start. The first one is the containers and orchestration tool. Okay, so how many of you are playing with Docker? Okay, so Docker by far is the best way to build microservices. Why? Because with Docker, you can put your code, you can put your dependencies, you can put your configuration, you can put your libraries into one single image, an immutable image. And then you can distribute this image across a lot of environments. You can have staging 1, staging 2, and then you can have the UAT, even the production. So whatever it runs on your laptop or staging, it will run as well in the production. So there's no annoying bugs, as in like it works on my laptop. It's no more. But then again, the discussion that we have currently running on the internet is not the how to package your applications into container image. We are talking now on how to orchestrate that. Yes, containerize your application is easy. On your laptop is easy. You can use Docker, you can define your Docker file and then create an image and push it. You can even pull it if you want. That's easy. But the problem is how you can ship it from your laptop and then to the integration environment, staging, UAT into production. And no, we're not talking about only few servers or a VM instance. We're talking a lot of them. How about that? How to ship your applications into these environments? And we're not talking about only doing in one AZ. How about the multiple AZ? And how about shipping into a multi-region? This is kind of discussion that we have right now. And this is why that we have a container service from AWS, which is really amazing. So this is all the layers on container service landscape. We have 3 layers: management, hosting, and image registry. So if you want to manage, you want to have managed service for your containers, you can use Amazon Elastic Container Service. Or if you're playing with Kubernetes, you can use Amazon EKS. So if you're playing with Docker, you can use Amazon ECS. If you're playing with Kubernetes, you use EKS. Okay. So and then hosting is going to be it's really fun. You have two options that you can host your containerized application on Amazon EC2, or you can build your own serverless containers using Fargate. Fargate is a really amazing service. You only need to have your image of your Docker, define the configuration for the network volume, CPU, or memory, and then you give it to Amazon ECS, and it will run on serverless mode. You don't need to manually scale it. It's a serverless containers. And because of these benefits they are getting from the AWS Container Services, our customers love it. From Adroll to Adobe to BuzzFeed and McDonald's, they've been using Amazon ECS to run their system. Okay. So the next best practice is how to automate your software release process. So how many of you have designed your CI/CD? Oh, it's only a few of you. Really? Okay. Okay, so you need to start building your CI/CD pipelines when dealing with microservices. Okay, so this is the same diagram that we have on the earlier slides. CI/CD, it can be like continuous integration, continuous delivery, or continuous deployment. But on the bottom of the slide, I put it DevOps continuous asterisk, a wildcard. It can be anything now. It's not only integration, delivery, or deployment. It can be continuous monitoring. It can be continuous compliance assessment. It can be like continuous risk management. It can be anything right now. So if you run your CI/CD, don't only run it, but own it. And this is the model release process in Code Pipeline. We have this service called AWS Code Pipeline, which you can model your software release process using a really nice workflow. You can use your own GitHub, or you can use a code commit, and you can build using code build, and you can still using your testing stack. And then you can deploy it to your production, or you can deploy it to testing environment, and then you can get the approval batch first before you deploy to production. It's really convenient way to build your CI/CD. But this has already been done. What we need right now is how to harness our CI/CD. So let's say that in your team, you have new developers. These new developers need to get an access to S3 bucket, right? And then you grant him to create the S3 bucket. But without your knowledge, he set up the S3 bucket on public mode, storing all the information your company have. The question is, how can you prevent that? So with Code Pipeline, you can model your software release process, and you can integrate with various AWS services. In this example is AWS Config and AWS Lambda. So let's say that there's a new Git commit. There's a new update on your code. You build it with code build. It passes. Everything's 100% pass. And then when it comes to deployment, it needs to check to the SNS topic, which will trigger AWS Lambda and call the AWS config to check whether this new updates is compliant or not. You can define your own rules. You can give a rules that Amazon S3 should not be public. And once that is satisfy all the rules, it will return back to the Lambda function. You can inform Slack to notify the changes, and it goes back to the code pipeline, and then if everything is okay, it will deploy to production. So this is what I mean. If you're building CI/CD, don't only run it. You need to own it, because this is really a crucial time to make your system more secure. Okay, so another thing is how to build asynchronous communication and lightweight messaging. Okay, so I would like to get a case from NASA. So NASA has built this service called Image and Video Library. You can go to images.nasa.gov. They are collecting all those images and videos from half a century ago as the knowledge of how they explore this vast universe. So they're collecting all images and videos, and they use Amazon SNS and Amazon SQS to operate this service. So whenever new content is uploaded, it will go to Amazon SNS. It will trigger the Amazon SQS to decouple the service and ask the service to process the image of videos. And this is a good example of asynchronous communication. I mean, most of the times we're building with synchronous communication, but asynchronous communication, you can get more benefit as well. So let's, for example, we have a publisher. This publisher publish a topic to SNS, and from one SNS with attribute filtering, you can dispatch to 3 queues. Imagine that. You handle your own routing using one single SNS. And then this SQS will put into the queue, and we have microservices to process it. You can use Amazon ECS, you can use AWS Fargate, you can use AWS Lambda or Amazon EKS. Okay. So, talking about microservices, talking about distributed system, the complexity is on the interactions. Okay. How they can communicate, and how can you make an order of these microservices to talk one to another? How can you ask them to interact one to another? So the third best practice is to define workflow to reduce complexity on interactions. I would like to introduce you to AWS Step Functions. AWS Step Functions is one of my favorite services because you can build distributed applications using visual workflows. For example, you have all these 5 microservices: order, inventory, invoice, logistic, and notification. You can think of it as a Lego. And then you can build a service workflow by combining all of those microservices. So when you start these step functions, it's going to call the order service, goes to inventory service, invoice, logistic, and then going to notify the customers. And then the workflow ends. It's an amazing service, which you can organize, you can order your microservices to interact one to another. A great use case from step functions is coming from Yelp. So Yelp is a service, whichever cities you're in and you want to know the best recommendation on that particular location, you can ask Yelp. So Yelp using step functions to decompose their monolith into microservices. Okay, so we've talked about the asynchronous communication and service workflow. And this is how it looks if you combine all those 2 together. First, we have a publisher, publish to SNS topic. With the attribute filtering, you can dispatch to 3 SQS queue. And then it can call the AWS Lambda to ask the step function to start. And on the right side, we have various service workflows composed by a lot of microservices. Okay. And then the next one is, how do we communicate with clients? The only way that we understand on communicating with the clients is through the synchronous communications. For example, an HTTP API, get the request and return the response. That's synchronous. But dealing with asynchronous, how we can communicate with them? So I'd like to introduce you to Amazon API Gateway, which has new feature called WebSocket support. It's really amazing. Why? Because now we can have a fully managed WebSockets that's easily to configure with Amazon API Gateway and has a lot of integrations with other services. Okay, so I'm going to do a demo, but this demo will try to share with you on how we can build microservices using AWS services. And I like to get your help by interacting on this demo, okay? Okay, can we switch to the terminal? Okay, so before we start, because it's a live demo, I need to get the blessings from demo God. Hopefully demo God's upon me so I can do this live demo. Okay, so how about if we ask the demo God directly, okay? So I'm going to ask him using the WebSocket. Okay, so I'm going to message him like this. Request. I'm doing a live demo. Let me emphasize the live one. Can you see it? Okay. At AWS Summit Singapore. Can you help to make sure everything is okay? And then we send it. Let's see what's his response. Oh, okay. That's nice. Okay. Message. Thanks. Thank you. Appreciate it. Oh. Oh, better be hurry. I'm going out for lunch anytime soon. Okay, so let's do the demo. Okay, so before so there's an URL. You can go to this URL first. And I'm going to walk through how I built this demo. Okay, so this demo use WebSocket using Amazon API Gateway. Okay, so this is the URL. It's bit.ly/14-demo. Okay. So I'm using WebSocket to communicate with clients. I use Amazon API Gateway here, which will dispatch into 4 type of requests: open connection, disconnect, send message, and default. So when it connect or disconnect, it's going to store or remove the connection on DynamoDB. For everything else, for every request, it goes to Amazon SNS. And this Amazon SNS, with one topic only, I can dispatch into 4 queues. So I have 4 queues. The first one is the queue message, which we will try to send all the communication from the microservices to the clients. It all goes through the queue message. And then the queue vote, when you vote it, it's going to this queue. And then we have the queue result to give you the results of the total votings. And then the last one is ping, to give the heartbeat, to inform the WebSocket, please don't close the connection. Okay? So every the microservices, I have 4 here. They are workers. They are not HTTP based. They are totally standalone applications using AWS Fargate. So everything is on AWS Fargate. Okay? So, and then for the vote, it's going to start the DynamoDB. And AWS Lambda will go through Amazon SNS to notify the queue message here, the worker message, to send back the results to the clients. And the client means your phone or your laptops. Okay? Okay, so when you see the results, whatever happens, can I get a round of applause? Whatever. Okay, we can practice it. Okay, awesome. Okay, so let's do the demo now. You can go to the bit.ly/voting/demo. Give me a thumbs up if you're already on the page. Okay, awesome. And this is how it's going to look like. Okay, I know it's going for lunch. I'm going to teach you a bit. So here you need to vote. Which one which your preference? Is nasi lemak or nasi padang? Okay. So let's vote it. Okay, so I'm going to give you the console, and I'm going to vote it. Okay. Yep. So here we go. So when it goes to the WebSocket, it's going to request to the Amazon API gateway, and the Amazon API gateway will return back to the Amazon to AWS Lambda to give the to trigger the Lambda on Amazon SNS. So you can see here that we have ping. Yeah. So we have ping, and then we can get the text is pong, right? Here. And then if I go to my console, see DynamoDB, I'm sorry. Sorry, Amazon, sorry, forget. See, everything is done by AWS Fargate. It's a serverless containers. Okay. And the serverless containers, we're going to get the Amazon SQSQ, and then going to process it and store it into the DynamoDB. Okay. Oh, I have 4 minutes left. Okay. So let's finish the slides first. I have 4 minutes left. Let's go back to the slide. Okay. So next one is the dealing with microservices means that you have hundreds of components of services. And you need to understand your service better. So the complexity of the modern architectures is a wide variety of the resources. And the complexity grows exponentially. The question is how you can handle it, right? The answer is you need to implement service discovery. So you can give the information to your microservices to find the location of a service provider. For example, it's my app or my logs with a specific IPs. So for example, like this, on this diagram, we have a web server running on Amazon EKS. And we have a backend component running on Amazon ECS with Lambda and auto-scaling group. And we have shared logs on Amazon S3 and RDS. But can we make it better? This is the service which you can understand your resources better. You can use AWS Cloud Map. So instead of seeing this, you will see this. You can place a namespace for your infrastructure. Like for example, for the EKS, for the website, you can put frontendapp.com and the backend app.com. So instead of calling the IPs and port, you can call them by namespaces. Okay. Okay, so let's switch back to the demo. Okay. Here you go. So we have 397 votes for nasi lemak. Okay. Congrats, nasi lemak, you won. Okay, so this is a simple demo. Even in this simple demo with microservices, you need to build like a 4 workers like what I've done. Okay, so let's switch back to the slides. Okay, and if you are doing the microservices containers as well, and you're looking for a fully managed service mesh, you can use AWS App Mesh. So with AWS App Mesh, you can control all the configurations on application level for all of your services. So you can easily monitor and control microservices App Mesh with App Mesh. And it's already available in Singapore. You can integrate App Mesh with Amazon ECS, Fargate, and EKS. Okay, so for the summary, microservice is a distributed approach design to overcome the limitations of monolithic. This is one message that I want to share with you. If you don't think that you're able to move to microservices, don't push yourself. Because when it comes to distributed system, please expect distributed problems. And understanding all of these components, you can try to find which AWS services that can help you. And one more thing, that I know that some of you love to manage your own Kubernetes, right? That's cool, that's awesome. But there's one thing that you need to remember, that the more granular control of your system also means that there are more moving parts, which will increase the complexity. Use managed service to help you. Use Amazon EKS if you're playing with Kubernetes. Use AWS Fargate if you want to run your containers on serverless mode. It will make your life easier. And don't let the software pipelines hold your backs. Prevent non-compliant application. So enhance your software release process by extending your CI/CD. And optimize your microservices by combining asynchronous and synchronous communication with lightweight messaging. And the last one is manage your cloud resources better with AWS Cloud Map and AWS App Mesh. So the next breakouts here is we have RT, we prevent serverless lifecycle. And we have, if you are into building mobile apps, we have Brian and Paul Sears, and DevOps for Windows application. Okay, so last thing that I want to share with you, please complete the session survey. Your feedback is really valuable for us to understand what your needs for next year. And I would like to say thank you for every one of you to build products, to build your apps, because it helps to improve our ecosystem to get a better world. Thank you, everyone. Go build.